Hello there. This is a project that I really wanted to do. It's been done sort of before because, tungsten grinders are kind of a dime a dozen. But I wanted one that I didn't have to pay a fortune for a start and that has some specific features. One, I don't want to disable my Dremel grinder. I want to be able to use it. So I wanted a quick connect and be able to slip this collet on and take it back off again quickly and easily. So, I keep doing that because it's fun. But there you go. So this is just for air circulation, and so you can see it. And this is the typical tungsten grinder. It has holes. The light's terrible. It has holes to slide the tungsten through. And the flat surface of the grinder is right there, and when it's spinning up, the tungsten slides through the hole, and we get the desired result. The fit is nice and tight, so you get a repeat grind that's the same every time, and I've had really good results welding. The pleasure of using the same exact angle every time. It's not so much a particular angle, but the same angle every time, and the same surface polish every time. It makes a Wolfram electrode really arc nicely. Yeah, the arc starts and stops nicely. And the heat's easy to direct in a specific area. So this one uses the basically any diamond wheel you want, as long as it's standard size. I specifically wanted to use the inexpensive ones you get on Amazon that are whatever, less than $1 a piece. And they last really well. Probably 100 grinds at minimum. I haven't counted, but at very minimum 100 grinds. I did a whole project with this wheel, and being that it was a new piece of work to me, and I'm a starting welder, I dipped the electrode a lot, and so I used the cutoff slot a bunch. Hopefully you can see the shop dirt on this. And yes, this is an inexpensive 3D print of the product. That's not what I'm proposing that we put together. I have a Swiss CNC machine shop partner who will produce these. And in a decent sized run, several hundred of them, they shouldn't cost more than maybe 20 bucks a piece plus something for the nut. So I think we can do it, given enough people want to do it. For maybe 25 bucks for the assembly. So I'd like to try. I'd like to make them out of 2024 T3 aluminum. That opens the way to a nice anodizing job. And they can be anodized to make a different color, for instance, for every size. Initially, I want to do a run that is 1/16 electrode hole. See, there's the hole for blunting the tip. And there's the angle hole for sliding the electrode in, and the one on the other side, see a little more clearly, that one is 22 degrees, the other one is 16 degrees, so you can get a slightly more blunt or sharper electrode for relatively fine work, which is what I typically do with a 16th inch electrode. Did not want to have multitudes of holes in the same collet if the collet's removable, because it's much easier, on me anyway, not to figure out which hole to stick the thing in or which slot. It'd be easier just to take this off and put an 1 for an 1/8 inch electrode back on. I don't swap electrodes during the course of a project. Typically, I'm more or less using one electrode most of the time, in fact. And if that's true of somebody they go back and forth a lot between electrodes, this is easy to change out. But for the time that you're using it, you don't have to figure out which hole to put something in. As far as the angle goes, I'll take feedback on that. We can make them in a set of angles that the most people want. I really like the 16 and 22 degree for my work. And it may be possible during a run to shift that one aspect of the machining and produce collets with several different angles. I don't know yet. So, but for now, I'm proposing that we do a 16 and 22 degree. So again, a recap. It's quick detach so that you can use the Dremel tool, which I do all the time. I use this constantly in the shop. Yes, it's plastic, but the finished result will be 2024 T3 aluminum. The holes will be machined as precisely as tungsten electrode comes, so that there is 1/1000th or more clearance, but it's a nice smooth fit. It doesn't wobble about as the electrode touches the grinder surface. So that way you really do get a precise skirt, that little round circle at the top of the taper, where it joins the electrode. You don't want that wavering back and forth. It disrupts the arc, so you need a smooth circle around the arc. And that comes from having a tight fit on the electrode in the grinder. It's really that simple. So I'll give a shot of it working.